Hi students, good morning all. Let us start the second part of this topic, rotational dynamics. We already know that we make two parts of this topic. First part is a circular motion and second part is a rotational motion. So write down part second, part second, and these two parts are for our simplicity, not specifically given in your textbook. Rotational motion, rotational motion, write down the part second, rotational motion. REM, rotational motion. This is our second part of the topic, rotational motion. Now, for the clear understanding of this remaining part, we must know about this important phenomenon called as a rotational motion. We already discussed clearly the circular motion, in which the importance of the circular motion is one of the important fact for the life on the earth. Similarly, 1 day, 2 days are due to the rotational motion and responsible or one of the important fact for the life on the earth. And therefore, the study of this phenomenon is also important. And before going to start this part, we must clearly understand this phenomenon like a phenomenon of circular motion. And therefore, for the clear understanding, I would like to compare the rotational motion with linear motion. And therefore, your understanding becomes easy and clear. Even if this part is not discussed in your textbook, what is rotational motion, what is linear motion, but I would like to give you these two uh, definitions for the further simplicity of this topic. So write down the question. This is our question. What are linear motion? What are linear motion and a rotational motion? What are linear motion? What are linear motion and rotational motion? This is our question, and as already discussed, this is for only simplicity, not in your syllabus. Write down first this phenomenon, linear motion. Linear motion. Now the example of the linear motion is shown here. This is a linear motion of a body. If you clearly observe this motion of the body, then it is very easy to define the linear motion. When I push it through some distance, say it as a 1 centimeter, and due to that displacement, suppose that this is a linear motion, and from that we are going to define the linear motion. So observe it carefully. When we displace the body through 1 centimeter, then each and every particle of the body is has also same displacement. And if each and every particle of the body has the same linear displacement, then we can say that this is a linear motion, and from which the definition of the linear motion is the motion of a body in which each and every particle of the body has a same rate of change of linear displacement is called as a linear motion. So write down the definition of the linear motion. The motion of a body, the motion of a body in which the motion of a body in which each and every particle of the body, each and every particle of a body, each and every particle of the body has same, each and every particle of the body has a same rate of change of a linear displacement, linear displacement is called same rate of change of linear displacement is called a rotational motion, is called a rotational motion, is called a rotational motion. And in comparison with this phenomenon, linear motion, we are going to understand the phenomenon of a rotational motion. Now, if this body is in linear motion, we know that then each and every particle of the body has the same rate of change of linear displacement. And if the body moves like this, then this is a rotational motion, or this is a rotational motion. Now, the difference between these two definitions is, in first case, linear displacement is same, and in the second case, that means in this case, the angular displacement is same. So only one word is replaced. Instead of linear displacement, we are going to use angular displacement, and so the definition becomes slightly similar. So write down here a rotational motion. A rotational motion. Now this is our remaining part, and even if this definition is not given in your textbook, I would like to give you for your clear understanding. So write down the motion of a body, the motion of a body in which each and every particle of the body and every particle of the body and every particle of the body has the same rate of change of angular displacement. Angular displacement. Underline this main sentence. Angular displacement is called is called is called a rotational motion. Now, after understanding the phenomenon rotational motion, we are going to study it. And for the study of this phenomenon, we know that we require a physical quantities. So let us understand what is the first physical quantity. And the first physical quantity is the moment of inertia. So write down the name of the first physical quantity. Write it as first moment of inertia. Moment of inertia. In bracket M.R. The important question, write it as a VIMP, will be asked on this point as define moment of inertia. Define moment of inertia and give define moment of inertia and give its a SI unit and dimensions, and give its SI unit and dimensions. Let us see first its a definition. Now, the definition of the most important physical quantity for the description of rotational motion, the moment of inertia. The moment of inertia of a body about a given axis of rotation, because this axis and this axis is different, and therefore in the definition axis should be mentioned. The moment of inertia of a body about a given axis of rotation is defined as the sum of product of. So it is a sum of a specific product, and that product is mass of each particle and square of its perpendicular distance from the axis of rotation. And so the definition is the moment of inertia of a body about a given axis of rotation is defined as the sum of the product of mass of each particle and square of its perpendicular distance from the axis of rotation. So write down this definition. The moment of inertia of a body, the moment of inertia of a body the moment of inertia of a body about a given axis of rotation, is defined as is defined as the sum of product of mass of each sum of product of mass of each particle mass of each particle and square of its a perpendicular and square of its perpendicular distance from the axis of rotation. This is our definition. It is denoted by I. And therefore I is equal to m1 r1 square plus m2 r2 square plus up to plus mn rn square plus up to plus mn rn square. And so the compact expression is I goes from 1 to n mi ri square. This is the main formula for the moment of inertia. And for the uniform distribution of mass, these are discrete distribution. First mass is, if it is say 1 kg, second is 2.3 kg, any. And if the mass distribution is same, like a rod, pipe, etc. So write it. If the mass distribution is uniform, then mi is expressed as, then write down here, I is equal to r square dm, integration of r square dm. I is equal to integration of r square dm, where dm is an element of the mass, where dm is the mass of the element, where dm is mass of element. And from the formula, SI unit is kg meter square, and dimensions are dimensions of I is equal to kg means m raised to 1, l raised to 2 and t raised to 0. These are the dimensions. Write down these dimensions: m1, l2, t raised to 0. And the points for the note are mi of a body depends on The mi of a body depends on first mass of the body, mass of body, second distribution of mass of a body, distribution of mass of a body from axis of rotation, from axis of rotation, that is on the axis of rotation, that is on axis of rotation. And third is shape of the body, shape of body, because the sphere has less mi while the cube has more mi if both having same mass. We know that the moment of inertia is an important physical quantity. Therefore, in order to understand the meaning of moment of inertia, this question will be asked. So write down this question. Give the physical significance. Write down this question. Give the physical significance. This is also VIMP point. Give the physical significance. Physical significance. Give the physical significance of mi. Write down this question. Give the physical significance of mi. Now, in order to understand the meaning of the quantity moment of inertia, let us consider the physical quantities in linear motion and in rotational motion. So, draw this table. In answer, please draw this table having two columns. First is for linear motion and second column is for rotational motion. The second column is for rotational motion. Rotational motion. Now let us see the first physical quantity, force. Now force is equal to mass into acceleration. Here the first physical quantity is torque, and the torque tau is equal to I into alpha. Now see the second quantity in the linear motion, it is a momentum. Now the momentum P, linear momentum P is equal to m into v. Now here the second quantity is angular momentum. Angular momentum. Angular momentum L is equal to I omega. Now write down the third quantity, kinetic energy. Kinetic energy E linear is equal to half mv square. Write down the third analogous physical quantity, rotational Ke. rotational kinetic energy. E rotational is equal to half R into omega square. See carefully the physical quantities in these two phenomenons. Now, this table shows that the role played by mass in linear motion is same as that of the role played by mi in the rotational motion, and it shows that the mi is the analogous to mass. That means as the role played by mass is same as that of the mi, so mi is analogous to the mass. But mass is a linear inertia. Similarly, movement of mi is a rotational inertia. So write down. It shows that the role played by mass in linear motion, it shows that the role played by mass in linear motion is same as that of role played by is same as that of the role played by mi in the rotational motion. And thus mi is analogous to mass. As mass is the measure of linear inertia, is the measure of linear inertia, as the mass is the measure of linear inertia. Similarly mi is a measure of rotational inertia. And this is the answer of the physical significance of mi, and it shows that mi is analogous to mass.